So what I want to do today is sort of do a whistle-stop tour through open access publishing, and from the perspective of an open access publisher, we're a not-for-profit and we're PLOS. So I want to talk briefly about the policy landscape, and then talk more about what actually being open means. And we've touched on this before in terms of it's now much more of a network of research, and how we can adapt to that network and how we need to adapt to that network. And then I want to introduce these two concepts about reducing friction, which is about increasing the usability or the utility of researchers' work, and being able to maximize the number of people you can reach. But we'll see how far we get. So we know about HEFGI's policy, but there are plenty of other policies in the UK that you're probably aware of. And it's not just in the UK, but it's actually all over the world. There are policies in the States, in Argentina, in Australia, some great policies in the Netherlands, in Austria. And so everyone is moving in essentially the same direction. And there are many different publishers. There are not just PLOS, but there's other pure open access publishers, some of which are for profit and others not for profit, such as Biomed Central, which is owned by Springer, Frontiers, which is partnered with Nature and Nature Publishing Group, Hindawi, which is a for-profit publisher, Copernicus, which deals more with sort of engineering and the physical sciences, Coaction Publishers, and there are increasingly a new wave of open access publishers in the humanities and social sciences, including Open Book Publishers and Ubiquity Press. There are also plenty of subscription publishers now with open access policies, including Oxford University Press, Wiley, Nature, Elsevier, and societies themselves are beginning to launch open access journals. AAAS Science announced that it was intending to later in this year. The Royal Society, Nature has already. So just to tell you briefly a little bit about PLOS, and we're both a publisher and an advocacy organisation, which is not just about open access publishing, but it's about leading a transformation in research communication. We're 10 years old, and we're so far the largest not-for-profit open access publisher. We publish 7 peer-reviewed journals, which I'll tell you a little bit about. We're based in San Francisco and in Cambridge. I worked in the Cambridge office, and so there's some remote offices both on the east coast of the States, in Australia and in Scotland. And we've been self-sustaining since 2010. We relied on grants and funding before that. And again, talking about this has come up a few times. What does open access mean? And for PLOS, it means, firstly, free access, free to read. It means absolutely no embargoes. It means that you can deposit the same article that we publish in our journals immediately. You can also put a preprint of the articles up on archives if you wish. And it is about very liberal reuse licenses. It's about ensuring that others can use their work, use your work even commercially, as long as it's appropriately attributed to you. And that's absolutely vital. We also have, we charge publication fees, but we have a publication fee assistance program. We haven't raised our, the charges we charge for an article processing fee since 2009. We've given away quite a lot to authors who haven't been able to afford to pay for article processing charges. But increasingly many governments and funders now provide dedicated funds for APCs. And while we offer assistance to authors who can't, they need to be able to demonstrate a financial need. We also have a global participation initiative which depends on, for example, gross national income, and we reduce the levels of charges we have for those countries. I just want to make the point that not all pure open access publishing or open access publishing charge a fee for the articles. People often equate gold with charging for an article, but actually about half open access publications don't charge a fee, pure open access publishers. Yes, so we have 7 journals. We have 2 which are very exclusive. I'll tell you more a bit about these, but we charge a fee of $2,900 for those. We have 3 which are run much more like society journals. They're run purely by academics, and the fee for making those open access is $2,250. We have PLOS One, which I'll definitely dwell on a bit, which is cheaper at $1,350. And PLOS Biology, and this is similar for PLOS Medicine, it's highly selective. There's about a 92% rejection rate. All our journals are peer-reviewed. This is our flagship journal that we launched in 2003, which was basically to show that you could have high-quality publishing and make it open access immediately, no embargoes, complete reuse. And so this was a sort of helped set the brand for PLOS, and PLOS Medicine was very similar. It came the year after. The community journals, again, they're highly selective, but they're within certain subject areas. PLOS Biology and PLOS Medicine are run by professional editors. I was a professional editor on PLOS Biology for 10 years, and that's why they have a higher article processing charge. They're much more selective. The community journals, like many society journals, are run purely by academics. They handle all the peer review, and they make the decisions on all the papers. And then PLOS One came along, and up to this point, PLOS had looked very much like a traditional publisher. And we only made one comparatively small change to PLOS One. It still had to be, any papers submitted and published there had to be rigorous and ethical and properly reported. However, the editors and reviewers in peer review do not ask how important the work is, nor what the relevant audience is. And this means, therefore, that everything that deserves to be published can be published. The journal isn't artificially limited by size. It also means that things like negative results can be published, or small case studies, the sorts of articles that are hugely important to biomedicine and understanding whether, for example, drugs work or not, but which are the articles that many journals don't like to publish because they don't get cited. Just some statistics for you. There are more than 4,500 academics running the peer review process on PLOS One. Accepted papers are peer reviewed by 2.9 external experts on average. The acceptance rate is high, it's 70%. And when you think about that, most research is funded by governments and funded by taxpayers. It goes through some kind of a review process. One of the questions I have is, why isn't the acceptance rate higher? That means 30% of what we're receiving is fundamentally flawed. Possibly, I don't know. In fact, we see some of our articles going to other journals and getting published elsewhere. We also, there's a training thing. Sometimes our academic editors want to try and push up the impact factor or whatever they see as being important, and they sometimes make errors of judgment and are judging on novelty. But there is an appeal process for those sorts of situations. We're publishing more than 140 articles per day, and the average time to first decision is 40 days. The other thing is many PLOS One papers are in fact highly cited. This is a frequency diagram. Probability represents frequency on the y-axis. Lots of papers are published many times. At least 10% of papers have at least 29 citations. This is from papers published in 2009. And this is the sort of distribution that actually you'll get for many, many journals. And it's also why the impact factor doesn't make sense at all. And even we thought, when we first launched PLOS One, that we thought it might work. We had no idea how successful it was going to be. We've had absolutely massive support from authors all over the world, and this is reflected in the growth of publications, the number of articles we've published each year, which was over 30,000 last year. And the success of the journal has now been mimicked with either the same or very similar editorial models launched by all sorts of different publishers, including BMJ and Sage and others. And although Alma was right this morning to say that open access is still a very small percentage of the total total number of articles if you consider subscription journals, the actual growth of pure open access publishers, so these are ones like PLOS, has been incredibly rapid. And I know that the figure for 2013, which is about to come out, will be about 120,000 there. I'm a member of the board of directors of OASPA. and this is something that does concern people about the quality of some open access publishers who have taken advantage of a new and emerging market. And so we conduct, our members have a code of conduct that they have to sign. We review the memberships and the criteria they use. And we've recently published, along with the Committee on Publication Ethics, the Directory of Open Access Journals and the World Association of Medical Editors, Principles of Transparency and Best Practice in Scholarly Publishing. And that acts as a very useful guide if you want to tell your academics or your colleagues where you should be publishing. Check the journal that you're publishing with against these sorts of principles and make sure that they adhere to them. And some people said, actually, that there was a paper that came out, a science metrics report, that there was 50% open access in 2013. Well, that's not open access. We don't think it's open access in terms of what we mean. It might have been free access after some embargoes and things. But there's no doubt that we've reached a tipping point in terms of open access. And so it's no longer a question of if open access is going to happen, but when and how we can manage the transition. But what actually does being open mean? And at one side of the equation, it means that your work or my work can help someone. And this is ideas that have been developed by Cameron Nayland, but it's just a way to look at what openness means. And the probability that you can help someone with your work will depend on the proportion of people that are actually interested in your work. Now, for some subjects that might be very small, for other subjects that might be very large. It also depends on the number of people that you can reach with your work. And finally, it depends on, even if the people who are interested have access to your work, how usable that work is. It depends on the ease with which they can actually reuse your work. But there's the other side of the equation, which is somewhere out there can actually help me or help you. And in this case, it's the proportion of people out there that actually create work that you're interested in. It's the number of people you can reach through your institution or whatever. And it's the ease with which those other people can contribute work that then you can reuse. The number of people that are interested in your work or that you are interested in is fixed. But ultimately, what you want is the ease of reusing that information to be as small as possible, and the number of people you can reach to be as large as possible. So being open is acting to reduce friction or increase reusability and to maximize the reach of that work. And this applies for both outgoing information and incoming information. And that's whether you're an academic or an institution or a funder. And of course, why does it matter? Well, we've already had this mentioned before. Scientific information is a public good. And we hold a public trust, and it ought to be made available. But also technology has changed, and the number of people we can reach is potentially limitless. We don't need to silo information in journals anymore. We can have both a network of literature and data, and of course a network of people, as Jane was talking about in terms of social media this morning. And networks have common properties, whether it's a network of regulatory proteins of this bacteria on the left, or an information network among ants on the right. And when networks are small, they tend to be fragmented and unconnected. And again, this is work that Cameron Nayland has done, where he's basically simulated the connections between networks. But then at a certain size, the number of connections between and within networks suddenly increases, and you get this huge leap where you get large interconnected networks. And that's the idea of open access. The idea is that if we can create an open enough environment, we can create a network where you can extend the reach of your work by a massive amount. And where we actually are in this graph. I think we're still down here with lots of small fragmented networks, and the aim is to try and push the number of connections and increase openness until we get that large shift where there is a much more open network. And of course, what would this enable? Well, some of the best examples, you might have heard of this is Tim Gower's weblog, and he posed the question whether you could actually collaborate with other experts that you didn't know about and solve a mathematical problem. And I'm not going to go into the problem, I have no idea what it is. But he didn't know whether this would work. He put it out on February the 1st. He put out this intractable problem that no one had yet solved in maths. He didn't think it would be solved. And within a month, the problem was solved, and using collaboration with people that he never met or never knew. Another one, which is also very famous, is Galaxy Zoo. This is a crowdsourcing project where they got the general public to measure different attributes of galaxies. And they had hundreds of thousands of people take part in this project and map galaxies that the astronomers wouldn't have been able to do themselves. There just weren't enough researchers. And it even applies to the humanities. This is a Transcription Bentham project where they've made it public, they've made the manuscripts public, and people are able to come and transcribe the work and make it available. And Martin Hall, chair of GIST, said recently, without openness across global digital networks, it's doubtful that large and complex problems in areas such as economics, climate change and health can be solved. And it's time that senior leaders made openness and its consequences their concern. But one of the issues about it is actually, while those networks are small, we have a few good examples like Galaxy Zoo and Tim Gower's of demonstrating why reuse is very important. But there aren't that many really good examples. And Google and PLOS and the Wellcome Trust got together to try and last year, and we provided an award for individuals using open access to provide innovative solutions to their research. And I won't go into this in detail, but it's available if you look up ASAP Awards on the web, and you can find out about it in more detail. But the next thing we need to do, of course, is we have this network. How do we adapt to it? And one of the big questions which has come up already this morning is about research assessment and whether the communication trail that we've had for many, many years is now fit for purpose. And this is a paper that was published in PLOS Biology last year, where Adam Mayer Walker and his colleague took two different data sets where scientists had, or assessors had ranked the same paper more than once. And the data set came from a faculty of 1,000 and also from a Wellcome Trust grant application panel. And he wanted to know whether scientists could assess merit or predict impact. And merit was whatever made scientists rank those papers highly. So he wasn't defining merit as such. And he wanted to see whether the scientists could both assess merit or predict impact in terms of future citations. What he found is that there were very weak correlation. It went down to about 10% between the assessors ranking the same paper. And moreover, it was very strongly biased by the journal in which the paper was published. Not only that, but scientists were also very poor at predicting the future impact in terms of whether their assessment of merit could predict whether an article was going to be highly cited. And this is partly because he concluded they're not good at assessing merit, but also because articles accumulate citations essentially by chance, and especially the amount of citations you get is inflated depending on the journal that you also publish in. So journals, if you publish in Nature or Science or PLOS Biology, you tend to get more citations than if you publish in what's termed lower ranking journals. And one of the reviewers, Carl Bergstrom, said what this paper shows is that whatever merit might be, scientists can't be doing a good job of evaluating it when they rank the importance or quality of papers. From the lack of correlation among assessor scores, most of the variation in ranking has to be due to error rather than actual quality differences. I think another conclusion is that scientists have different ways of assessing merit. What's important to one scientist isn't necessarily the same to another scientist. But the last research assessment exercise cost the UK government £60 million, and so it's not quite clear what the assessors are adding to that. He also showed that he did it for 2 assessors for 1 paper. He then modelled what would happen if you added 3 assessors, and essentially you get the same result. And you'd need multiple assessors before that correlation between assessors in terms of ranking increased. And not only that, the number of citations or the impact factor exaggerates differences between papers, and assessor bias can affect the ranking of universities and tenure. So one of the ideas, and this is actually what PLOS One has done, was to abandon subjective ratings of articles. Don't get scientists to assess the importance of the paper. Make them published and then see how important they are afterwards. And in fact, there are now, as Ben was talking earlier, there's a whole range of different approaches to peer review. And I'm not going to go through these in detail, but we've got everything from preprint servers, which are now becoming available for biomedical subject areas. There's bioarchive. There's more open peer review, where it's completely open and you've got signed and published reviews, or where you've got reviewers commenting on each other's reviews and assessing each other's reports, but remaining anonymous to each other. There are also a new range of independent peer review services, where you, as an author, can actually pay to have your article independently peer reviewed, sometimes for a fee and sometimes not. That article and the names of the reviewers then be passed on confidentially to a participating journal. And the idea is that this helps speeds up the peer review process. It perhaps separates it from publishing, but you can then target the appropriate journal or venue where you want, where you think is most appropriate. And then there's a whole suite of journals also looking at post-publication assessment, including perhaps most recently PubMed Commons, where if you have published in PubMed and if you have an article in PubMed, you can then you can then comment on other people's articles. And this has actually opened up a whole range of debate about articles that are out there. But of course, lots of people care about measuring impact. And we know there are, the impact factor is used. We all know what the problems are with the impact factor. Can be manipulated. It doesn't tell you anything about the individual article itself. And recently, PLOS and others actually signed up to what we call the Declaration on Research Assessment, which is where we call for the need to focus on the merits of the individual article itself, rather than the impact factor of the journal. And lots of people are signing up to this, and there is, I think, funders and funding bodies are also interested in trying to find different ways to measure impact. So how can we measure impact? And one of the ways, and we're not the only one, PLOS are not the only ones doing this, is to look at article level metrics. And I'm going to go through this relatively quickly because of time, but it's about looking at not just citations, but usage, social networking, blogs and media. And here's an example. You can go to a site which will tell you about our article level metric program at PLOS. But this is just one article in PLOS Biology, and on the front page it gives you some sort of headline news in terms of how many times your article's been viewed, how many times it's been cited. That's using Scopus citations. You can then go to a metrics tab and you can bury down into that, and it can show you different types of citations, including where it's been discussed, where it's been tweeted, if it's been mentioned in a faculty of 1,000. And we think that there are different ways that people are using the different metrics. It's still a very new field, but there is research being done on it. And so whereas scholars will tend to cite articles, broader impact might be reflected in terms of downloads or social networking. And then finally, in the last few minutes, I want to talk about reducing friction and how you increase the usability or the utility of your articles. And the first thing is about data publishing, and this is actually a graph which shows that the longer a paper is published, the less you can access the data from that paper. So after about 5 years, you've got only fewer than 30% of the papers actually you can get the data from. There are also there's plenty of research out there about the fact that many published papers actually are false. This is a famous article. It's now, I think, reached 100,000 downloads by a statistician called John Ioannidis. But it's not just access to the data that's a problem. There's also whole issues around transparency, about how articles report the data, whether the information is used for biomedical sciences, it's whether they've actually controlled for the experiments correctly. And there is an issue about how we can address this sort of problems with the research literature at the moment. And it's related to open access, because if there are these problems within the paper, then even if you make them open access, they're not useful to the people who can use them, because the information is either wrong or not complete. And so PLOS and other publishers are trying to raise reporting standards in paper and improve access to the original data sets. We now have a data policy which we ask all authors to have a statement stating where their data is made available in their papers alongside, and this is published actually with the paper. And there are initiatives to try and increase the reproducibility of original studies. Now, of course, a lot of this applies to the biomedical sciences, but some is equally important to the humanities. And finally, I want to talk about maximising reach and how we extend the articles to as wide an audience as possible. And one of the things that has come up in conversation today is the lack of understanding that people have around what open access actually means. And Spark, PLOS and OASPA got together to try and create a guide to show you if you had an article or if you had a publisher, how open that publisher was. And this has 6 different variables, which goes from both reader rights down to how much an article can be reused, even whether machines can read the article, whether you can post your article in third-party repositories or to repositories or websites. And it tells you the different types of spectrum. So ultimately, what we've got at the other end here is the most open option for all of those, which is the one that PLOS and other pure open access publishers use. We're also trying to create reporting tools that allow you to see the open access status for a different set of articles. And this is, we hope, is going to help people. This is still very much work in progress, but we hope it's going to help people report on what proportion of articles they have that are open and what licenses are associated with those articles. And so, for example, this is, I'm not going to tell you the funder, but this was a particular funder. We did an analysis of papers in PubMed that they had published since 2008. And so, for example, in 2013, they had published 252 articles. Only 228 had DOIs, not all of them had DOIs. Only 6 had a CC BY license. And 20 was stated as being published in open access journals, which I think also shows you that not all open access journals have the same type of license, and not all open access journals have a license where you can reuse the information. And very finally, the most difficult stage is trying to manage the transition between the subscription publishing landscape we have now and the open access landscape. And again, these are things we've talked about over the day. What we need to do is to try and minimize costs and avoid replacing big subscription deals with, for example, big deals on article processing charges. We want to discourage double dipping. We want to be able to foster competition. And ultimately, we're all here for the same purpose, to sort of to get the research out there to people who can use it. And so we need a really effective collaboration, both between publishers and libraries, and between the new players that are coming in, for example, like Figshare. And ultimately, it's about how we all stay afloat. And it's about the quality of service you provide. It's about the value for money you give. And it's about sustainability of whatever product you're producing. It's about impact and however we measure that sort of impact. And our core business is to get authors' work into the hands of those who can use it. And I think that's the business of institutions as well. And it's about dissemination, not distribution. And it's about discovery rather than just filtering. And it's about platforms, not just services, and all sorts of different types of platforms, not just those provided by publishers. And it's about the freedom to build and construct and to reuse information, and ultimately to enable those uses that we can't yet even imagine. And that's why reuse and a license like CC BY is so important. Thanks very much.